When we think of cave systems, we usually think of one big opening, but caves are actually a lot of small openings that all combine together as they freeze and crack. One example of this you can actually see up there. You might be able to see some graffiti up in this little hollow that people have climbed up to. And that cave probably started off as a separate cave from the giant one that we're in right now. But as the cracks get bigger, as things freeze in the winter, these caves start to combine together and you get a larger system like the one I'm standing in. I'll talk you through all the different things that the limestone is doing behind me. You've got a river over here, which is carving out the limestone through normal erosion. But then you've also got a small little bridge. It's called Smoky Bridge. Eventually, as all of the soluble calcium, the old fossils in karst dissolve, what's left behind is really strong because it should have dissolved and didn't. So it means it must be a lot more densely packed and sturdy than others. This is the kind of limestone that's usually used in building materials, since obviously you make a statue or a house out of limestone that's going to dissolve in acid rain, you'll get a crumbling building by it. Now here's another view of Smoky Bridge. And you can really get a sense of what they mean by a bridge. It looks like what you would find underneath the highway, but it's completely natural. It's been carved out by this river, which is eroded over a super long period of time. And erodes it a lot more easily because the limestone dissolves so easily that I can carve it out a little bit faster than it would for other kinds of rock. Erosion is super, super slow, and that's probably why it's so powerful. I can barely even see the tops of some parts of this natural bridge that we're in, and you can see it goes on for a while. But the only force that carved this out was running water, which you can't really see it working right now. It takes a long time for it to carve something this large. That process of erosion is aided by friction, which is, of course, the water pulling against the rock and pulling those sediments with it, as well as gravity at places where waterfalls are, and then the ability for the chemicals in the water to dissolve some of the minerals in the rock. Another type of weathering you see is all these lichens and funguses that are growing on the rock. Most of the limestone, when it gets washed away and has a lot of water on it, won't be able to grow plants and mosses and stuff. But when you have an area that's been exposed for a while, it just stays damp and humid, but doesn't get washed away. So things can grow on the surface, and that breaks down the rock even more. It can convert a lot of the surface rock into soil. And we call that biological weathering, where the plants and funguses and mosses and bacteria that are growing in the rocks are actually what's breaking it down, instead of the water from rivers and waterfalls, which break it down through gravity. One of the most unusual types of biological erosion I've seen is right under here. We're actually underneath a little cave mount, but you can see these ferns growing here, like they're actually leafy plants. They get barely any sun though. We're totally underneath this cave. So the only way these things could grow is A, they're getting a ton of water, which is enough to feed their photosynthesis. And then they must be getting a lot of minerals from the rocks as well, probably infiltrating through the rock and then landing in their roots that they're pulling from it. So that just a little bit of sun is enough for them to be able to survive. Now you can see that they've grown their leaves to angle it so they can get as much sunlight as they can, going downwards instead of growing upwards. We normally think of plants going up towards the sunlight to catch it. That process is called phototropism. It's basically a behavior the plant has. Even though it seems like it's not living because it's so still, they grow towards particular things that help them survive. And so these plants have a phototropism growing downwards because the sunlight is coming at the bottom instead of up above them.